So we have our original trig functions, sine, cosine, and tangent, and we know they come from taking a right triangle and labeling the opposite, adjacent, and hypotenuse, and then writing the ratios. So sine, if you remember, is so from SOHCAHTOA. Here it is. So sine is opposite over hypotenuse, O over H. The reciprocal of sine is cosecant. It's abbreviated CSC, and it's what you get when you take the sine relationship and flip it over. So instead of O over H, it's H over O. Next, we have cosine. Normally, cosine is adjacent over hypotenuse. The reciprocal is called the secant, or SEC for the abbreviation, and you flip over the cosine, so we have H over A. Last, we have tangent. Tangent is O over A, opposite over adjacent. The reciprocal of tangent is cotangent. It's abbreviated COT, and we get it by flipping over O and A, and we'll have A on top of O. Basically, what you need to remember, because it's easy to remember that you just flip sine, cosine, and tangent over, is which word is the reciprocal for the trig functions. So I think it's pretty easy to remember that the reciprocal of tangent is cotangent, right? Those two go together. The rule is each relationship only gets one co in it. So you have tangent and cotangent. If you have cosine, then you already have your co, and just secant will go with it. And if you have sine, then you haven't used a co yet, and so cosecant goes with it. So try to remember those relationships, and that's what we'll write down when it asks for all 6. So that's example 5. So we want to find all 6 trig functions. Let's label our triangle. Here we have theta. Opposite theta is 48. Adjacent to theta is 14, and this is the hypotenuse. So let's go to write sine. Remember, SOHCAHTOA. If we can get sine, cosine, and tangent, we can get cosecant, secant, and cotangent. So sine is opposite over hypotenuse. So 48 over, oh no, we don't have how long the hypotenuse is. So what can we do to figure that out? We know this side's 14, we know this side's 48, we just want to know the third side, and so if you're thinking Pythagorean theorem will help us, you are correct. In Pythagorean theorem, C has to be the hypotenuse, and since that's what we're trying to find, we'll label that with C, and then it doesn't matter which one's A and which one's B. So we'll put 14 squared plus 48 squared equals C squared. If you type all of that in your calculator all at one time, you'll come up with 2,500 equals C squared. One more step, square root both sides, and we get C equals 50. Now we can write that number, 50, in for when we need H. So back to finding sine, opposite over hypotenuse. The opposite side's 48. The hypotenuse we now know is 50, and now we just reduce. So 48 over 50 reduces to 24 over 25. Now right away, since we just found sine, let's find the reciprocal, which will be cosecant. So we're just going to take the 24 over 25 and flip it. Next, let's find cosine. Cosine is adjacent over hypotenuse, so 14 over 50. We'll reduce it to 7 over 25. And now to find the secant, we'll just flip that over and get 25 over 7. Last, we'll do tangent. Tangent is opposite over adjacent, so 48 over 14. We need to reduce. We're going to get 24 over 7. To find the cotangent, we need to flip that and put 7 over 24. Go ahead and try example 5b. It's going to be the exact same where you're going to have to solve for the missing side. So here's a hint if you didn't figure this out already in 5b. When you do the Pythagorean theorem and you do 18 squared plus 80 squared, you'll get 6724. When you square root that, you're going to get that this side is 82. Then you should label from theta, the opposite side is 80, the hypotenuse is 82, and the adjacent side is 18. Now you can write the sine, cosine, and tangent, and then the cosecant, secant, and cotangent. So go ahead and do that. So here are all the answers in simplest form. Make sure when you write them down you put sine of theta, cosine of theta, tangent of theta, reduce it, and then same thing, cosecant of theta equals, secant of theta equals, cotangent of theta equals. That way we know you're going from this angle and not a different angle down here. If you take a look at example 6, A, B, and C, you'll notice that we have two sides of the triangle and we don't know the angle. See that? Two sides, don't know the angle. Two sides, don't know the angle. So if you ever want to find the angle, if you ever want to solve for theta, we're going to use inverses because inverses cancel each other out. So all you'll have to have are two of the sides. So what's going to get rid of sine so that we can solve for theta? Well, the inverse of sine. It's sine with the little -1 up there. That means inverse. So if you have sine inverse and sine right next to each other, they cancel each other out, and we'll be left with theta. But we can't just put sine inverse on one side, we have to put sine inverse on the other side. So if we type that into our calculator, we'll be able to solve for theta. Same thing for cosine. If we want to solve for theta, we're going to put cosine inverse in front of it so they cross out, and we'll put cosine inverse of the adjacent over hypotenuse. Last, if you want to cancel out tangent, you'll put tan inverse, it'll cancel out, tan inverse, and then you'll just type it in your calculator and solve for theta. So let's try these examples and it'll make a little more sense. This is our missing angle right here, so this is theta. Let's label the triangle just like we always do. Opposite of theta is right here. This is the hypotenuse, this is the adjacent. So let's figure out what we have. We have A and we have H. Which trig function uses A and H? Cosine. So cosine of our angle, which we don't know, equals 18, the A, over 54, the H. And now we want to solve for theta. So we're going to cancel the cosine out by taking the inverse cosine of this side and the inverse cosine of this side. So what you're going to type in your calculator is second cosine and then type in 18 divided by 54. So this is what your calculator will look like. 18 divided by 54. Type that in. When you hit enter, our answer for theta will be approximately 70.5 degrees. Let's try the same thing on 6b. We want to find this angle right here, so that's our theta. Let's label O, A, and H. So opposite theta is 22. The hypotenuse is 32, which means the A is over here. We have 32 and 22, so we have O and H. Which trig function uses O and H? Sine. So sine of theta, which we're trying to figure out, equals the opposite, 22, over the hypotenuse, 32. We want to solve for theta. We want to figure out what that is, so we have to cancel this sine out. How do we cancel sine out? Take inverse sine and take inverse sine. So in your calculator, it's going to look like this. You'll type second sine, so you get sine inverse. And then you're going to type 22 divided by 32, hit enter, and you'll get that theta equals about 43.4 degrees. Let's see if you can find the last one on your own. For 6C, you should have come out with about 38.9 degrees, and we used tangent for that one. Good luck with all your homework.